Good evening, everyone. So we continue with the second day of our 2 days lecture series. Uh, we will shall directly start. So I invite Mr. Vishwajeet to continue uh, with the discussion.
Yes, I'm sharing my screen. Is my screen visible?
Yes, it is visible.
Nice, thanks. Okay, let me check things. Okay, so hi everyone. So let's start the second lecture series for today, and this is the last one. And yes, so we will continue to the treasure hunt in the sky, and we will explore the rest of the parts, and then the few parts which was left in the last lecture. So yeah, so again, according to the outline, so today we will try to cover a few of the Gaia and Tumas catalogs, and then try to make a HR diagram using the tools and the both tools and Python. And then again, we will see the few science cases which can be done only using the archival data. Not they don't require the telescopes. And yeah, so let me revise that yesterday. So in just one word. So yesterday we covered in the basics that coordinate system. It's the array deck, which what we use for to define the coordinate of any source, and it is similar to the longitude latitude of Earth's coordinate system. And there is a distance which we will see in the Gaia catalog. There is a parallax angle. So using the parallax angle, we can find the distance. More the value of the parallax angle, lower is the distance. It means they are closer to the Earth in the Milky Way. And then again, from the spectral redshift, which is extragalactic sources, which are outside our galaxy. So to find the distance of those sources, we usually observe the spectra and then get the value from the redshift. And then magnitude system, it's basically measure of the brightness of the source, but it's a bit of it opposite that a smaller value is the brighter object. And then again in the filter, so we you will see in the different catalog we utilize the different kind of filter. For example, Penstar is using the SGSS filter UGRIZ, and then again SGSS catalog is also using the same. That for example, Nomad catalog are there. They are using Johnson filter, which is capital UGRIZ, and sorry, capital UBVRI. And then there are two mass filters. So the filter utilized by the two mass in infrared. So the standard are the JHK. So yeah, again, so these are the different kind of filters which have they can be narrow band, they can be wide band, and then they are basically allowing the light in particular band, and then getting we are getting the photon for that particular filter. And then last in the we check that we can have a population of a different kind of object in the HR diagram, and then they can tell us from the HR diagram if we are studying, for example, the cluster, they can tell us the stellar mass, age of the evolution, and we will see how we can uh, tell that what is which cluster is old, which cluster is young, and then again from putting the uh, object over the cluster, we can also estimate the from the color diagram and the level apparent magnitude. We can also estimate the distance of that object, or say the cluster, and then again, so this type of so this type of plot help us to uh, study the star formation reason, how the star evolve with time, and then we can also study whether how according to the masses. So again, so HR diagram can give us the mass. So according to that, we can also say that how the that particular star, for example, the sun, end up in the end of its life. Yes. Yesterday we again in from the catalog side we covered mostly the CDS system, which is mainly we go through the Simbad, XMatch, and VZR, and then there we learn that how to get the table out of the query. So there we have to select a particular catalog, and then we can do the cone search. Cone search it means that we are putting some particular array deck and then putting the radius around that, and then retrieve the table. And then from that table you can do the all type of get the all type of information and do the science. So yesterday we mostly covered getting the table. So today we will try to cover a few things. So how can we get the time series data? It means the data observed over the years. And then from there we can actually study the how the particular object evolve with time and all, right? And then again, so let's go through one by one. For optical and IR data, so there is a one famous uh, catalog, which is a pen star. So from the pen star, we can have a deeper image. So it helps us to find something, for example, if there is a host galaxy or not. So since the this pen star is a deeper, so we can find even the fainter host galaxy if it is present in the image. And then if that particular galaxy is of interest, if there's something transient or something happened, then we can check that. And then there is a IRSA services, so which is a service by the NASA, and then they are providing the mainly the infrared data. So too much and then voice data. So they are all the infrared data, and then they are also providing the ZTF time domain data, which is again ZTF is a GK transit facility, which is 48-inch square degree field of view telescope, and then it's a sky survey telescope basically. And then within a 48 hours, it can cover all the northern sky. So so it is observing every day and then giving releasing the data to the public. And then again, so there are the HST, JWST, and then those images can also be retrieved. And in the time domain, so if we want to find again that time series data, then there is a CFST, and then there is a ZTF again. So there might be other catalog, but as per I know, these are the mainly useful. But there might be more other catalogs, time series data we can find. And then in for the spectroscopic data, so again, the SGSF is famous for the spectroscopy. They have observed lots of the spectra for the stars, quasar, AGN, and then all. So even it's very old, but it is still robust to get if you want spectroscopic data. And then again, so currently the JWST is also observing the spectra in higher band. So in infrared, if someone looking into the infrared spectroscopy, then they can utilize the JWST data. And then there are the two spectra also observed by the Gaia data. And last is the Galaxy database. So in the Galaxy database, there is a one famous we mostly utilize is the NED. It is again by the uh, NASA, and then it's basically collecting all the kind of all the galaxies from different various sources, if whether it is published by someone or whether it is observed by the survey and all. So from all the various sources, it is collecting the data and then try to make a complete galaxy catalog. So, but so far, because there is a limitation by the ground based and again space telescopes that up to a certain limited magnitude they can observe. So then if the for example, if the galaxy is very faint of about 28 magnitude, then they can't observe that. So with the time, I guess the more distant galaxy can be observed if they are there. And then again, so this net galaxy is complete up to I guess 200 megaparsec, something like that. But yeah, so sorry, 200 parsec. But yeah, after that it is quite incomplete. So I will again go through the few of the websites so that we can have a feel how the data looks like. So let me arrange it. So yesterday I found that people might have difficulties to follow up from the slides to the. It's new. Okay. So is it okay for everyone to look like this? Or okay. So let's do like that. So yeah. So this is the pension catalogs. Pension website, and then there we can see that there are different catalogs. So this is the catalogs for the object search. If you want a table of that particular area of particular area and then certain region, then you can go to that. And then if you want image cutout, then you can utilize this catalog. And then again there are SQL query which is faster to get. So so it is similar to that which we did yesterday, and then from here you can also retrieve the table. And so from the Vizier which we did yesterday, from that we can also get the same table, and then directly from the Pencher image we can Pencher website we can get the same kind of table. But yeah, I think Vizier would be better to because it can give all kind of table in the one space. Okay, and then let's go to the image service. So this is the something, yes. So this is something where we can put the array deck and then get some of the images. Let me put something like it is. Okay. So so this is the here we can see this is a small cutoff. Let me make it like a bigger. So yeah, so here we can see that 600 arcsecond image, and then this is the object we can retrieve, and then from here we can directly download it and then utilize it for any purpose. So for example, we are also utilizing it for the image subtraction because they are deeper image and then they observed very early before, and then whatever the image we are currently observing, so we can subtract them and then get the new transients. Okay, so let's move to the next one, which is a IRSA service. So this is again another service by the NASA, and then from there we can download the data from the for the kits that ZTF wise and anything. So for example, here we can see the ZTF access. Here we have a catalog access. Similar, we can get the table. But let's say look at the images, and then yes. So let's M45 and then get the if searches, if entire searches, then we can select any of the options, and then let's have a search here. And then you can see, so it is giving the image, and then we can change that image field and all. But the point is, we can have a series of data. For example, here we can see that it observed from 2018, and then we can see that over the different data how it is observed, and then I guess we can get more data with at different. So it has almost 1665 of images at different time, and then from there we can check if something at a particular position, if there is some evolution happened. Then from start to different images, we can have the that evolution information from the different images. So yes, let's again. So there is a legacy survey as so this is you can say that version 2 of the SGSS. So SGSS is little bit shallower, but the legacy tried to make a complete northern sky with northern or southern sky with more deeper images. So their limiting magnitude is quite high. And by the way, limiting magnitude, I mean by up to what magnitude an object can be seen in that image. For example, limited magnitude of 20 means you can't see the object with a 21 magnitude. So JGSC survey is famous for the deeper images. You can download the images, you can get the catalog and all. Uh, Generally, the server is quite busy. So yeah, let's don't wait it for that and then move on. Yes, so there is one more service which is I found is very useful by the Canadian service. And from here again, so it is providing lots of the uh, catalogs. So here we can see the collection of the catalogs are here. We have JWST, we have HST, and then each instrument have their instrument. So for example, Hubble Space Telescope, there are different class of instrument, and then from each instrument they have a different filters, right? And then and accordingly you can filter it out if whatever what you require. But let's say if we need a particular JWST imaging, and then again we need to put the object and let's resolve it, say 42 and search. So currently it is trying to resolve the name using the symbol or and then it will give the result. Yes. So here we can see the bunch of the results we got, and then uh, I guess there should be a few images. It is trying to load. Okay. So anyway, so usually you can see the all the type of information the object which was observed by the JWST. So the particular RA deck, the start time and start time of the observation, instrument which is used for that particular image, and then if there is something already in a target name in the catalog and all. And then again, so from here you can actually download the data easily, and then it will download it. So yeah, again, so this type Canadian service is very useful, and then give you the download option to different type of data. So yeah, so this is the preview I was talking about. So here you can see, I guess this is not an image, that's why it's not showing. So spectra will not look like a image. So only uh, the photometric image can be show the uh, image like spectra. Okay. So anyway, so we will move on again, and one. Let me give you the one more example here. So again, I would like to show the CHFT data. So this is again very famous to get time series data, and then we already put the name and then search. So okay, meanwhile it is loading. Okay, so okay, so let it to be load, and we are now moving to the another server service, which is a transient server, and this server is mainly collecting all the transients, and then very famous for a collection of uh, supernova data. And then again, so they have an option for the supernova, FRB, and LVK data, the LIGO Virgo Cagra data, which is for the GW eventing. So yeah, so transient database is mainly famous for that. And then again, they are having agent data. And then in the for a particular case, if I see the supernova case. from in this you can get all kind of information: the discovery date, time, coordinate, magnitude, filter, spectra. If there is spectra, then you can also get the redshift, and you can also get the host galaxy information. So let's move to the tangent server. Okay, so here we can see that this is a tangent name server, and for example, if I'm searching just SN, so it will give me. You can actually put the coordinate, or you can uh, let's say put the proper name of the supernova, so you will get the information about that. But I'm just putting the SN so that I can have a full list of the SN, and then okay. Instead of wasting the time. Okay, yes. So it now here. So here we can see that it has bunch of the supernova listed here, right? And then who discovered it, and then what is the magnitude of discovery, if there is a host galaxy, what is a redshift. So if we can go to each supernova, and then here you can see the supernova type is there because according to the spectra the people analyze, and again redshift is there. Coordinate you can have, and then again so discovery date, and then from here you can directly jump to the Panchar images. So this is the Panchar one, and this is the Aladdin, which is in the Simbath, and then you can directly jump to the different kind of catalogs. If there is a host information, then you can search for the NAD and search for the Panchar, and then if you want to get the infrared information, you can search for the WISE. And then here you can see that someone posted the spectra, and then from the spectra, usually people uh, find the what is the type of this supernova, and then you can get the discovery time. But usually after that, people follow it up and then put uh, model the supernova and then publish the paper. But what
Sir,
the from sorry,
can I ask a question here?
yes,
Huh. So now we are searching this particular catalog and the data is there. So it also gives you the type of supernova. So which means somebody has already processed that data and categorized it, right?
yes,
So
yes,
so when typically data comes, I mean, who does that for?
yes. So again, so for this classification, someone need to first take the spectra. So in general, if it is not classified, so it will be the dash line. So it there will not be a type. But so usually, for example, Sky Survey telescope, if it is observing the sky and then found some new transients, and then any new transient will be reported here. But then if there is no type, because we don't know, okay, what is the type of the this what is the class of this object. So people used to take the spectra, uh, and then also take the more photometric data, and then from the evolution of the photometric data or from the spectra, people can mention that is it a supernova, is it some TD, is it some nova, and if it is, it might be a afterglow of some GRBs or merger events. So usually
So
follow up,
are people
yes.
using now machine learning for automatically categorize this?
Yes, so ZTF is famous for that, and then I guess in 2023 they publish this TNS post automatically without human intervention. So their ZTF telescope observed the supernova, and automatically it trigger and there another telescope which is SCDM to take the spectra, and then their machine learning based pipeline, they analyze the spectra and then automatically give the type of the supernova and then proceed it to the CNS. That this is a supernova, this is the spectra, and this is the type of the supernova. So currently, all the things are now automated using the ML and all.
Thank you.
Yes. Yes. So yeah. So why it is important? Because we can do the science study. So if you have a telescope, you can take the more data and then publish a paper. But again, so there are lots of the scientists which are using the already publish supernova, and then from there they can do the population study, and then collect all the kind of supernova. The particular, for example, you can do the spectral study of all kind of supernova, and then check if there is discrepancy. For example, if you are taking the spectra of just particular type of supernova 1A, and then there you can find if there is something discrepancy between the evolution in the spectra, and then according to that you can define that how what is the composition of that ejecta and all. So people used to do that. So again, so this help us to do the spectral analysis, the population studies, host environment analysis. So for example, if, people also doing the if there is supernova happen for different class of supernova, and then what are the active activity happening in their host. So that can also be studied. And then again, there are light curve analysis to model the bolometric luminosity and all, right? Yes, so this is the one of the first example for the science case that even so currently people are observing lots of the supernova and JW and then LSST, which is a new era of the astronomy. They can observe more deeper. Uh, they can take more deeper images. So there will be more different kind of more number of supernova, and then maybe different kind. So even again, so there are lots of the theory are still open question that why this light curve is particularly showing this behavior, why their spectra are like that. For example, one of the example is currently happened in September 18, which was a coincident. There was a transient which was coincident with the LVK, the JW event, and then that particular transient happened after that event, and then in there people thought that it is a just a supernova because its spectra almost similar to the supernova. But then later, few of the our group have studied that and then found that it can be a superkilonova. So uh, there and in the from the spectral and from photometric analysis, they found that there is a scenario where the supernova can also be observed, and then along with that, kilonova can also be observed. So yes. Again, so transient name server is also good for uh, LVK alerts. So as I mentioned, in so this is another science case that people can do is LVK alert. There, so you can pick up all the GW event, and then in there you can check. So this is why it is good for each LVK alert. It is collecting all the transients which happened after that, not before that. So if some new transient happened before the GW alert, then it is not relevant to us. But whatever the sources which has happened after that, then it is relevant to us. It might be a counterpart of that particular event. So it has a list of the all the transient which can be related to this object and not. So again, so people need to find that and then check the survey. So this is again a good archival uh, source to do the population study and then check if there is really some transient which can be associated with that GW event, and then if and then from other catalog services you can get the images of all the images and then check if it is associated with this particular event. Okay, so let's move on. So yeah, so let's discuss about few more science cases which we can study from the archival data. So yeah, so this is another science case which is GRV studies, and since I am the I'm mostly doing the work on transient, so I'm giving the more example on the transient, and then later we'll give you the more example on other sector of the science. So yeah, from the GRV study, you can say that there is a already published paper which published GRVs of 535 GRVs, and then in there they have all the photometric data. So they actually made a dedicated web page for query any GRV which was observed till date around 2024, and then they collected all the data from the papers and then GCN. So let me show you the GCN. So usually sorry, it's okay, so usually whenever there is a JRV trigger observed by the satellite, so and then they will post the JSON here and then post the notices also, so that the telescope and then other satellite can look into that direction. And then here you can see, for example, if this is one of the example we did in the 26th. So here you can see that. So first there was a SIFT GR. So SIFT is a satellite which detected this GRB and then observed its prompt emission in very high energy. Then there is a it's afterglow discovery by us, the GRT, the growth in the telescope, and then we published that we found afterglow from this particular event, and then this is a magnitude, and then other people then immediately follow it up and then give their observed magnitude. So you can see the number of the GSM which observed by the people and then give to the this particular platform. So so this is again public, and then from this you can uh, get the information of when this particular GRB happened, and then which telescope observed this event, and then you can also collect all the photometric data, and then again, so always use the if there is some already published data, then combined you can study the GRB, you can model the GRB study, afterglows or the prompt emission, and then interpret it. So yes, that for the GRB study, if you want, you can use the GSM circular, you can use the notices, and then you can use the already the such, for example, this paper, there are lots of the GRB and then all the photometric data are there. And then you can also use archival mission data. So for example, if during the time of the event, and if the Gaia is also looking in that direction, then that Gaia must have that data. So you can look into the Gaia and then check that whether there is more data from the other satellites. And then again, so from the redshift distribution, diversity, and then all kind of JRBs, you can study them and then publish the paper and then all. So again, these JRB studies also still open. And if there is a lots of the new peculiar thing happen every time, and then you can publish if you are finding something new in the photometric or uh, automatic or spectral analysis, and then again you can model it in a different with a different models, you can again different it interpret this particular event in a different way. So yeah, there are always be a open option for the JRB studies. Okay, let's okay, it's a half an hour. Let me ask the question, is anyone have doubt? Okay, I am not looking at the chat. I guess if there is no doubt, we can proceed. Okay, so
Yeah, we can
other
proceed.
yes, thanks. So other case is the star engulfing a planet. So this was my one of the favorite, which happened in 2023. So usually people assume that when the star died, and mainly the uh, exhaust is its main nuclear power, or say the hydrogen, then it expand, and then they can, during the expansion, they can engulf the planet around that. So same thing can happen with the sun. But this is an example where the that particular author find that there is an option that when the planet is orbiting around the sun, around a star, then due to the gravitational wave, loss of the gravitational energy, they can come closer, and then without a diode of the star, they can come close, and then star can be engulfed by the planet can be engulfed by the stars. And then how they find, and then it's a discovery basically. It's published in the Nature paper, and then it's in the 2023, and then how they find that, because it was almost similar to the nova. There is another class of event which is nova, but its luminosity was very low. So and then again, so since its luminosity is very low, so it's a like a cool event and low temperature, low energy event. And then this type of event can easily be observed in the infrared. So when they check the infrared data in the archival data, so first they discovered that object using the ZTF optical data, but then they check the archival data in the IR because this object is a low energy event. So then they found that there is a very sharp rise and then a significant rise in their light curve. And then from that they confirm that this is new class of object. This is not something which is already studied. And then after that they discover multiple similar kind of event from the archival data and then publish that. So this is a very good example where the if some kind of this kind of discovery happened, then immediately people can jump in and then check the other archival data and then do the catalog of that particular source and then publish it. So again, so it's all the race are there that who will publish first and then all this. But if there is some discovery, then it is always a chance that other can publish using the archival data if they found a similar kind of data from the other sources. Yes. So let's move on the other part. So this is a paper by the Gaia. So where they studied the particularly the HR diagram, and then so they are generally Gaia data is very famous for studying the parallax angle and then proper motion stars. So they have a very good value, large catalog and good values for the and accuracy for the proper motion where the star is actually moving around in the galaxy. And then again, so using the HR diagram of a different cluster and all, you can study that how the star evolve and then how the cluster which is a uh, group of stars are evolving and then how they are influencing to each other, right? And then for again, so from a nebula for the molecular cloud, how the magnetic field can affect their structure. So so people have I so for example people had done that. So from the color information of particular cluster and then they again observed that particular cluster in polarimetry and then found that what is the role of magnetic field in the formation of the star in the presence of a different kind of magnetic field. So yes, this is the example from the HR diagram and the Gaia. And then again, do the we will try to make a HR plot using Python and tool Topcat. So this is the another example, which is a ML classifier. So we already have lots of the data from the Gaia, SCSS, and all. So there, people are developing different kind of machine learning classification, and then from there they can just pass the data. So how they are basically passing, for example, they can select particular region and then they can have a multiple photometric data at different type and then from the evolution of a particular all the each sources in that particular region, then they can classify using the ML. And then there are different ML model which can classify that. And then again, so there are always be uncertainty that some error basically in the classification. And then there will always be a chance of a better model which can classify better. Okay, so let's move to the first. We will let's go to the Python code. I will share that Python code, and then we will come back. We will come back to the top 10. So I will share this particular Jupyter notebook I have made and then try to put uh, this explanation. And then, and by the way, it is very nowadays is it very easy to put the explanation using AI and then Jupyter anything. So yeah. So this is the so again. So my suggestion for the coding is first whatever the code you get is how to its first step should be the how to utilize that instead of going into the code and what is it is doing and all. So first try to always try to utilize that code, and then later you can go inside the code and then tweak and then get more out of it. So this is a, for example, get the table. The so what we are doing using the web page and then getting the table. So here this is the uh, function where we just need a cat num, and that cat num as particularly can be get from Vizier. So let me show you that. So as I mentioned before, but it's better to recap. So yes, so for example, if you want to query the Gaia. So from the Gaia, you can select which particular Gaia you want. There are data release 1, there are data release 2, 3, and all. So from here, you can, for example, this is a catalog number which we want to query. Then utilize that number, and then you can put here, right? And 49 is probably for DR2 photo astrometry. So it's a specially made data for particular task. But this is a data which is all the released by the Gaia. So there will you will find lots of the different kind of catalog which is match with other catalog and then form another catalogs. Okay, so here what is important is first we have to check in the function which what is the input. So we need a cat num, we need central array dec, and then radius. So here we put that from the cat num, and then we now we are querying the particular object that, for example, this the cat num is dedicated to pen star. If we want, we can put the Gaia particular Gaia 3, or the we can put this particular number, whatever you like. And then we can put the array deck, which from at what reason you want to get the that particular catalog, and then you can put the radius. So we call it con search. So in that particular radius, you will get the table, and then what is the output is also important. So here we are getting the output in the form of table. So this is a panda table, and so now here you can see this is the table we are getting, and then you can see all the columns in the table, right? And the length of the table. And then when you get the table, it is better to not load the table every time. It is better to save it in some local machine. So this is a particular function is made to store the table. So here you just table is saved in this particular variable, and then in that using that variable you can just put the name of the file name and then save it, and then it will tell you where it gets saved. So for example, here we saved it to this particular location, and or we can put a, particular folder where you want to save. And then here again, different other another example. If you save the table, then you want to load it at later. So this is the example that load the table using the file name. So you can put the file name if it is in the same path, or you can just give the proper path and file name, and then it will get load. So again, so to get to know how what is a path is pwd command. Then it means that currently it is in this folder. Whatever you saving is and whatever you try to load is it is looking in this folder. But every time if you don't want to rely on this folder, you can just put the path uh, separately. This is currently not much relevant, but yeah, this is a legacy search where you can get the sky view of the legacy survey, and then there it will actually circle that particular array deck. So currently it's not relevant. Yes, so let's come to the another part, which is DS9. So yesterday I put show the example that in the DS9 you can actually go to the analysis, which is a part of the DS9, and then go to the catalog and then load it. So let me show you. So here is one of the example that we have image, and then it's astromatically solved. So we can actually load the catalog from query. So we can go to the analysis and catalog and then optical, and then you can select anything. So usually I used to select the GSC 2.3 because it's more like a complete catalog for, and then it is famous for the astrometry, not for the photometry. And then here you can see that it since this image is the world solved into the world coordinate system, so it's automatically align each sources over the each circle over the sources. And then again, I mentioned yesterday that you can select the cat option here in the edit, and then whatever the cat click wherever you click the source, and then it will be you can see in the table, and then you can do the opposite. So let's assume that so again, so there are the limitation in this DSNN. So it don't have all kind of catalogs. So but let's say we want a deeper catalog, for example, Panstar. So we can actually download that and then load it. So that's why this is a code. So this is a code to create a catalog to download the catalog and then save it in the form of reason file, which is required to read by the DS9. So yes, so let's save it, and it will save at this folder, and then we can see this is here, and this is a reason file which can be read by the this DS9. So let's load it, and we will see. It's going very. Yes, so you can see it automatically detect the design file, and then we can change the color if you want, and then load it. I guess green would be better to visualize. So yeah, you can see that it queried the panchar and then save it into the reason file, and then we can see all the sources which is there in the panchar. But this image is has a lower limited magnitude, but it is not visible here. So, and then the value here is the magnitude in GRI. So again, so this code, how to use this code is mainly you have to put this value mainly, which is a table is a whatever the table you load in the query, you can load it here. And then array. So in the table, you have to be careful that what is the array key. So what is the name of the column name of that particular column, and then you can what columns you want to label it on the each circle. And then we did here the for example in the Pancha the array is written in the array column is a column name is array J200, and then similarly depth, and then we want to see GRI magnitude, and then it is displayed here. Okay, so this is the example for the DS9, and let's move to the HR diagram. So for the HR diagram, again, so we already made the function which is a get table. So let's we can immediately get the we can query that particular table and then save it. So I already did that. So this is a table, and this is basically 90,000. The length of the table is 90,000. So I'm not going to rerun it again because it will take much of the time. But you can see that I saved it in the desktop with the name of this, and then here we have that particular file. And again, so this is the query from the Gaia data release 2, and this is the particular array that we queried, and then this is the radius we want the reason for the catalog. And then again, we did the same thing for the 2 mass. So from the 2 mass catalog, we download the same table and then save it here. So again, you can see this is a table, and then we have all the columns and the values. And then the second table, we save it with the 2 mass. Okay, so let's go through the little bit of a column name. So here you can see the array and uncertainty is array, deck and uncertainty is the deck. So these are the position uncertainty. This is something the ID, which is a source ID to the source, and this is the uh, parallax. So this is in the milliarc second, and this parallax will basically tell you that what is the distance of that particular source. If you're taking the reciprocal of this value, you will get the distance in parsec. And then again we have a parallax error in parallax, and then this is again important is a proper motion. So there are lots of the star which is moving across the actually moving across the space. So it has a value the proper motion in the milliarcs again, and then error for that. And so yes, let's come to the magnitude. So we have a G magnitude, which is a wideband magnitude, and we have a RP magnitude and a BP magnitude. You can see is a BP magnitude and here is a RP magnitude, which is a uh, uh, little narrow magnitude, not much, but little narrow to the bluer side, and one is RP is to the redder side. And that particular filter is very useful to get to get the color of the source. So that's why there is a dedicated again column, which is a BP minus RP, which is showing that what is the color of that object. For example, BP minus RP is 2, which means the magnitude of BP is larger than RP. It means it is red because magnitude of BP is larger as compared to the RP, and then lower the value of the magnitude, it's mean brighter in that particular filter. So it's red, and then if you see the negative value, then it means it's blue source. Yes, and so again, similar to the from the 2 mass catalog, we can have a different kind of columns, which is so again 2 mass is an infrared catalog. So there the filter name is JHK, and then their effective wavelength is in the higher band. And then here you can see the JHK value with their error. And then these are the flags. So again, you have to be careful. The Whenever you are getting the values from a catalog, so it is always be there. You will always find some kind of flags which is in the catalogs. And then here is a, for example, it's a quality flag, and then uh, it's probably a reliability flag or something. This is a C is a contamination flag, and there are the different flags. So currently, I'm not aware of all the flags, but yeah. So whoever is working on this particular catalog, then they should search for that. What is the meaning of this flag, and then what if you want only the good sources, then what should be the flag for those? Okay, so let's load the table. So here, instead of querying again, we just load the table, and then so again, we have now two table. So now we want to cross match it. So to cross match, so that so for the cross matching, we need to put these are the inputs. So for example, one is a table one, and then in the table one, what is a column name of the array and deck. So this is a array one key, and this is a deck one key for correspond to table one. Similarly, for the table two, and then you have to define what is a separation you want to put here. So do you want to, so there is a 3 arc second, so it means that two sources, if it is within the 3 arc second, then it means that it is the same source. Otherwise you can decrease it if you want more accuracy, or you can increase it if you want, then the error will be that, then there might be a chance that the two different sources get in the same. Okay, so again, so to utilize this function, we just need this input, and then we run it. So it will give you the match source. So now in the table, you can see it is a combination of two different catalog, and then the corresponding each rows is corresponding to individual star and object. So in the star, you can see the values from the mainly from the Gaia, and then up to after that you can see the from here it is starting the value for the 2 mass. So again, so in the code I dedicate intentionally put underscore two, so that if the two name there is a two common name, then it should not be confused. Then so that's why I put underscore two for the 2 mass. And okay, so now the next part is to get the HR diagram. So color diagram, color versus nuance diagram. So yes, so this is a just generic example to show that we utilize from the table we utilize the G magnitude, DP magnitude, RP magnitude from the Gaia, and then we calculate the absolute magnitude from the G GF magnitude, and then we utilize the parallax here. So again, so we have apparent magnitude. If you want to get the absolute magnitude out of apparent, you need the distance, and distance information is stored in the parallax. So I directly utilize the formula from the paper, but it is quite simple if you derive it. And then we get the color magnitude. So color is just a difference of two magnitude in different filter, and then we plot it. So here we did not put much of the filters in the plot. So you are getting almost very scattered uh, plot. So here in the y-axis it's absolute G magnitude, and in the x-axis it's basically color, right? And then since you will see that these objects can it's not coming from the same cluster, right? It is coming from the all the object which is in that particular region. So let's filter it out. So yeah, so after filter, you can see that we put a particular kind of filter, which is here we put more filter. For example, we only want the rows which have finite value of G, BP, and RP magnitude, and then again the parallax. And then again we put another filter here, which is a Pleiades. So let's say we want to this particular array deck is pointing toward the Pleiades. So and then we know from the paper that Pleiades has a parallax of around 7.3. So we put some uncertainty and then get the filter out the table with the parallax having the values in between these two, 6.5 and 8.5. And then we tried the same plot again. So here you can see it's filtered out. So all the background stars, all the other stars get filtered out, and then you are getting probably most of the star here is the main sequence star from the Pleiades cluster. And then there are again, so there are a few of the contamination here you can see. So yeah, to do the same thing, I made a function. So in this function, you have to utilize this thing. So again, you have to put the table, which will be the match table. You have to put the expression. So X expression means you want uh, what is the column you want, right? And for example, in our case, it's a BP minus RP. So it will automatically
So,
calculate the ratio. Sorry.
uh, sorry, there is one query here, maybe
Mhm.
directly can be addressed. What is mask bad parallaxis?
Okay, that's a good question. So in the first quarter, we can see that we particularly plotted all these sources in that particular cone region. But this region is containing all the sources at different distance, right? But in the HI diagram, we want sources from the same cluster. So which means it is cluster means there are the group of the stars which form at the same time, and but their luminosity and mass can be different and radius can be different. And we want to study that whether this cluster is young or older. So it depends that how much older star are there. So that's why so parallax is again indicating the distance. So inverse of the parallax will give you the distance. So here we know that for we want to study a particular cluster, so we want to take the sources at particular distance. So in the terms of the parallax, the Pleiades cluster is at around 7.3 milliarc second. So we, in that sense, we put the mask so that we can look in the particular region. So we put the mask so that the all the in the table the parallax value should be larger than 6.5 and then less than 8.5. So this is our uh, filter of the match table. So And then in the resultant, if you put the mask to this value, then and the resultant table will be basically all the sources which has a parallax value between these two values. Is it okay?
Yes, I think Bradish must have got the answer. He said thank you.
Yes. Right. Okay. So yes. So likewise again, so we made the table and then we will directly instead of going to the coding, we will directly utilize it. So this is an example how to utilize that. So whatever the x-axis and y-axis you want, so you have to extract that from the table. So for example, I want to extract all the information from the table. So one is the Gaia G, BP, and RP band, magnitude, and then I extracted the parallax from the Gaia column, and then I extract the this is a C flag from the two masses. So this is a flag showing that if C flag is 000, then it means it's a good source and a real source. And then again I extract the parallax error from the Gaia column, and then we are extracting all these values from the match table. Then we can build a mask. So in mask, what we want to constraint in for that particular table. So we put the constraint. One is the these values should be finite. There should not be infinite and some null value. So we put that constraint. And then in the parallax, we want a parallax value of more than zero. So again, so due to the error, there is a negative value, but they are not real, right? So that's why there is a you put the parallax for the greater than zero, and then again you want a low value of error for the particular all the error for that corresponding parallax value is should be low, and then it should be less than this value. And then again we put the particular parallax constraint for the Pleiades, and then so again so this constraint is particular for according to the cluster you want to study. And then last is the C flag. So C flag is an example you can use. It has more other flags, but this is example that where we I know that C flag 000 means it will take all the good sources, and then you have to run it. So in the run you have to put the table name, and then you have to put the expression. But so what do you want what should be the x-axis, and then again what should be the y-axis, and then you can put the mask. If you have some mask you can put it, otherwise you can put the none. And then you have to label the x-axis and y-axis, and then the title of the image. And here you can see the result that the similar kind of result we got. However, there are some extra sources I am seeing, but yeah, I will debug that later. But yeah, so for some reason I don't know, I am getting little bit of extra sources here, but in the previous code I did not get that. So we will look into that. But mainly to show this example is we got the main sequence star, and then of that particular Redis cluster. And then here you can see that from the HR diagram, if the main you are seeing the most of the star on the main sequence star, then it means that that cluster is young. If you go to the nebular cluster or the older cluster, then you will see there will be deviation from here. So because again in the so this x-axis is the color, and the lower value of BP minus RT means the object is very hot, and then it's blue. Blue means hot, and then usually the hot star die fast because they have their mass is very large, their radius is large, and then they burn their source of hydrogen very fast, and then and then going evolve to the red giant or something. So again, so you will see if there is a if it is a getting older, then you will see more of the cluster here from this same if that particular cluster get old. Yes, and then a similar kind of plot we can made from the two mass, and then here you can see the we again put the expression for the color, which is j minus k in this case from the two mass, and then again in the y-axis we just plot the j magnitude in the epsilon magnitude, and then this is a plot. So here we can see that in the redder side there are little bit of evolution as compared to the optical uh, graph HR diagram. There is a little bit of deviation here in the IR. So I currently not much aware of that. What why is the deviation? But so the my guess is so these are the stars which is low mass stars, and then it's uh, probably getting hot or something. Its luminosity increases. So okay, and uh, okay, it's so here we have a little bit of deviation. I don't know, is it the main sequence chart? Is it the main sequence? And then if this is a deviation from the main sequence, then it is this cluster is probably getting to the lower luminosity. And however, their temperature is still same, so it is going toward the lower radius and lower luminosity. So probably they are also burning their fuel and then getting to the low luminosity and lower radius, something like that. I am currently not sure. Okay, so mainly the two. This is a example to show how to make the HR diagram from the uh, what you say the Python code. Let me quickly show you the similar kind of thing from the top cat. But how much time extra can I take? 5-10 minutes, is it okay?
Yes, sir.
Yeah, thanks. Yes, so I was distracted by the sir. Yeah, I'm a PhD student, so please. Uh, yes, let me show you the software. So yes, so for the time constraint, I already opened few of the tabs, and then will show you. And then again, so in the presentation, I put the link. So again, so I'm not much using this code of that code, but I want you to have it because if you are struggling with the code, but you should not stop the studying, right? So from the catalog you can utilize the publicly available tool and then get to the end part of the result, and then from there interpretation is also important. So if a people is very good in interpretation, for that this particular tool is very important, and then they should use that. So I put the link, and this is the YouTube link. From there, you can check more, and then it is the same where from where I have learned. And then okay, so let's start with the TopCat. So when you open the code TopCat, you will see uh, the window, something like that. And then you have to again mainly load the catalog first. So first go to the file and then load the table, right? And then in the new window will open up, and then here you can do the cone search. So again, so this tool will automatically query the archival service and then get the table. So here you can choose the whatever the server you want to choose. So there, I guess the first one is by default by the top cat, but other are the default one by the other services. And then here you have to put the keyword name for that particular catalog you want to load. Load it's Gaia DR2 which I want to load, and then find the service. So let's find the service here. So you will see which list of the catalog which you want to load, and then you have to select it, and then put the. Then you have to come to the search, which is giving the array deck. So I already put the array and then deck, and then again you have to select the radius, how much catalog you want. Then I put the select the arc minute and then put the radius. This is the same radius and this is the same array deck which I have done in the Python code. So yes, again, after you put OK, it will automatically load it and then uh, load it and then show the table here. So here it loaded and then show the table, and then you can immediately view the table. So here you can see I click on this particular table icon, and then I can see the whole table, right? And then if you want to see what is the column name and all, you can just click in another this icon, and then you will see the all the name of the columns, and then their description is also in the right hand side. So it is quite useful to go through. So in the single place, you are getting uh, all the information. You don't have to go to the different web page and then search and all. So you are getting all in a single tool. Okay, so yes, from a given table, we can plot multiple things. So, for example, if I want to plot a sky plot, so we can uh, load it and then plot it as a sky plot. Let me check. So currently, I think I did few of the steps, so it is showing less number of table. Let me, if you are going through the same procedure that I am showing, then you will see something like this. Let me load that window. So yeah, so when you first load the table, you can click on that particular. You can click on this 3D table plot. You can click on this sky plot, and then you will see uh, something like this, right? And then here you can see that it's basically globe. It's quite weird, but yeah. So you can see this is the globe of celestial sphere, and then each on each point is indicating the array depth, and then this is a particular reason which we queried, and we call it concepts, right? And yes, to the plot. Okay, so let's move to the different plot. So yes, now you all plot this. You see the how to get the sky plot. Now we are going to plot a 2D plot. Sorry, 2D plot. This one. So here you will get the uh, tab to plot anything from the column of that particular catalog. So here you will see in the X and Y you have to select which plot you want to show in this particular plot. So for example, if I selecting PM array and then if I'm selecting PM deck, so it's proper motion in R and proper motion in deck, you will see the sources here. And then you can see that X and Y, and then it is showing the different cluster. And then you can also play with that. So let me show the table, the plot which I loaded before. So yes, so this is something I loaded before, and then here you can see that you can also play with that. So one of the interesting play which I found is a blob. So if you're clicking in this blob sector, right, and then select particular region. So for example, I can make a shape over that, and then click again. So it will tell you, do you want to make that particular blob as a another subset. So it will make another subset. So I already made a few subset, and then here you can see that. So this is the small cluster. So originally the plot is like that, and then I made the blob here, and then a small cluster. You can see that this is a small cluster I made the blob before, and then it basically separating out that particular cluster, and then again it is separating it the table also, and then again let me show you. So what is interesting I found is clicking. So if you are clicking here at any position, so in these two different plot, you can see that it is going to the same source. So if I'm clicking here in the one plot and want to see what is the array deck and what is the array deck in a different sky plot, you can see it is pointed out here. So this particular object is same, it's here, right? Okay, so let's plot a few other things. So again, so this the reason to plot this the this plain plot is to get a separate cluster out of the main cluster, and then we will check that particular cluster. And then again, so if you are plotting anything from this catalog, because you already made a different subset, you will get the different color for that plot. You will see that. Okay, so let me show you one more thing, which is a histogram. So if you click here, again, this is the main window, and then here is the example for the histogram. So again, so histogram is showing that how many value are there for a particular region of the uh, x-axis values. So again, if I am selecting anything, for example, let's say parallax. So you will see that it is making the histogram of that particular parallax. Okay, so before what I obtained is something like this. So here you can see it plotted all the subsets. So the original plot is the red one, and then small cluster is another subset, and then main sequence is another subset. It is trying to plot everything. So, but we can uh, remove that from here. So from the subset, you can select that and then remove that, and then you can play with that. So let's say we have different histogram over there, but it's showing over the main histogram. So you can normalize it basically. So I guess normalization can go from bins. Yes. So in the bins, you can normalize it to the maximum. So you can see here that all the all the plot now showing the at the same level. So it's normalized from 0 to 1, and then you can see each plot one by one. It's quite, probably yes. So so yeah, it's a histogram. It's sorry, subset, and then you can see one by one. And again, so again, useful tool in the sense you can actually fit. So let's check that. Mm, correct. Yes. So in the form, you can do more analysis over that particular histogram. So for example, I already loaded it. So you can add the Gaussian, you can add the other function and all, and then it will plot it over there, and then it show the Gaussian well over each subset. And then here you can see the values for the. So this is a values for the all, and then if you want to see the value for the different subset, then you can go and then check what is the mean value of that Gaussian plot and what is the standard deviation and what is the factor. So here the example is you can actually uh, fit Gaussian over your histogram. And then I guess there are more, you can explore more of such a type of plots. So yes, let's next part is CDS cross match. So one of the again which we did in the Python. Yeah, we can do the same here. Let me show you. So this is again same window, and then we are going to join, and then in join you can see the CDS upload X match. So it is matching to catalog, and then or either you can directly click on similar same icon and then get the window. So here again, so here you have to select which catalog you want to match, and then and then you have to select your main catalog with respect to which you want to match. So here I have main catalog this one, and then this second table is the cross match one from the two masks. And then it automatically you just have to go, and then it automatically will produce, uh, let's say, the new table list, right? And then, okay, mm, yes. So if you go, it will probably open up mm, new table. So yeah, yes, you can see in the right. So new table is created and then it's added. It's basically same one as before, but it added to the main window. And then here you can also label it whatever you want. So okay, so let's do the cross matching. So so now now it's this table is now containing all the sources and then which is present in both the catalogs. So here you can see the table and then you can see that total value is 558. So whatever the from two different catalog we queried and then we found a 558 cross match from that particular bulge which we selected. So it's this. Let's show you. This is this is with respect to this small bulge, which is indicated by the blue one.
Sir,
Okay,
uh,
sorry.
in, uh, in 5 minutes we will conclude
Sure. Yes, sure, sure.
because there will be another program
Yes,
followed by this. So,
yes, yeah. So yes. So this is the example where we can get the cross match table, and then again we check the information, and then similarly plot again. So let's do one more thing. So we can again open up the pie plot, and then here we can actually now select the table, and then from there we can again select the which is a what is a x-axis, what is the y-axis. So I already did that. So let me show you. So this is the example where I try to plot. Main the that plate that particular area which we queried and then try to plot HR diagram out of it. So again, we tried G band magnet at the y-axis, and then again we tried BP minus RP. So this BP dash RP is actually BP minus RP magnitude, which is already present in the catalog. And then you can see there are the cluster of the main sequencer and there are other cluster. Again, here we did not put any parallax limit and all. So here we are seeing almost all the cluster. But the good thing is if you want to study a particular, for example, this particular cluster, so you can again go to the blob and then select it. So it will automatically select it and then make and then you can make another subset out of it. So I already did that. That's why it's showing by the green color. And yes, so last thing I would like to mention, and again, so for if you want a on a particular plot from a particular catalog list, so if you're selecting this list and then you can plot, it will only contain that particular table, and then you can plot that accordingly. So currently this plot is out of all the full Gaia catalog. And then the last thing is very interesting from this service is going to this service. So if you click this, it will open up this new window. And then in this new window, you can click on something like display HIPS cutout. So if you are clicking that, you will get the chance to uh, select the which survey you want. So this particular click is basically to view the image. So when whatever the data point over the plot is there for each that point, you can actually view the actual image which is taken by the instrument. So I already loaded the two mask. So you can go select and then go to the particular catalog, and then I loaded the two masks and then I queried it. So after queried, you can see that it automatically bring the image. And then interesting part, which is again quite interesting, uh, is selection. So if you are selecting particular source, So it is selecting this one here and this one here, and then so from all the graph you it pointed the same object, and then with time it is basically taking the time, but with time this will automatically update. So yeah, so this tool is very interesting, and then you can explore more. I my main aim is to give you the idea that there is a tool exists, and then you can do such thing, and then you can go through that tutorial from that YouTube link, and then you can do the similar type of thing, and then even it is always better to export of some tool so that you can do anything if you want from the catalogs. So yes, that's I conclude here, and I guess thanks everyone, and if there is any question.
Participants, you can ask the questions now. Please don't leave. I'll just put the poll for feedback, and then I request Professor Bore to propose vote of thanks. By that time, you can put your questions here, and I'm just launching the poll. So please answer the poll. The poll is launched. Please answer the poll. I request Professor Bore to propose vote of thanks parallelly.
Okay. Uh, Thank you, Professor Mahesh. Dear participants, for 2 days, that is yesterday and today, uh, Mr. Vishwajeet has explained so many tools and the way in which you can access the data and complete your projects, which is undertaken at UG level or PG level. The universe is supposed to be vast and there is no limit for it. So in the same way, there is no limit in analyzing the data which is available today. And it is better for you to learn at least one or two tools initially and get acquainted with and go ahead. I must thank Professor Vishwajit for making it at least accessible to us so that how to start and where to start and how we should go ahead. Thank you, Vishwajit. I must also thank Dr. Varun Valerao because of his initiative. We could carry out this program. At the same time, the principal of Wilson College, uh, I thank on behalf of IAPT. I also thank Mrs. Rekha Gorpade, General Secretary of IAPT Central, who came yesterday and introduced IAPT in a very well manner. And at the same time, the coordinator who is very meticulous in accessing and putting the access to all the students and all the teachers also. The faculty of Wilson College is also available, were also available for both the rates, and I must thank to the faculty members of Wilson College also. And dear participants, thank you all for attending this program and keep waiting for the next program which will be launched by IAPT and Wilson College together. Thank you all.
Thank you, sir. Thank you, Mr. Vishwajit. Thank you, all participants. Please uh, put the feedback, and the recording of both the days by next week will be available on both Wilson College YouTube channel under the playlist of Physics Department and IIT Mumbai Sub-Regional Council's YouTube channel. So, you can then make use of these and fulfill your projects. Uh, Thank you all for being here. And please complete the poll. Only 14 people have till now given the poll. We want everybody to give the poll. Thank you very much. Thank you, Mr. Vishwajeet. Uh, See you for some next program which we can make
Sure.
more elaborate.
Sure. Thanks, everyone.